Hello, welcome to our program, Astronomy for Everyone. This program is brought to you by the members of the Ford Amateur Astronomy Club in Dearborn. My name is Don Glazer. With me today is a member of the Ford Amateur Astronomy Club, Sandra Masika, and she's going to talk with us today about observing Jupiter. Now, Sandra, where can we find Jupiter in the sky?
Thanks, Don. Jupiter is going to be beautiful for the summer and the fall, and it rises in the east and is mostly toward the south, and you'll see it coming up late in the beginning of September. It's going to be rising quite early before the sun actually sets at just after 7 p.m. So you might just barely see a bright light in the sky coming up, and towards the end of September, it's going to rise well before at 5 o'clock. So the sun will be hours away. It'll be starting to come up in the east, and then later in the evening, by about midnight at the beginning of the month, or 10 o'clock at the end of the month, and you can go halfway in between. If you're halfway, it'll be about 11 p.m. You'll find it right at its highest peak. That doesn't mean it's going to be its highest overhead. That'll be the highest that it actually gets, which will be, so look towards the south, and maybe about halfway up, or a little less than halfway up around that time, about, like I said, midnight towards the beginning, or 10 p.m. Towards the end of the month, and it'll be the brightest thing in the sky there.
So they won't be able to mistake it for anything else? It'll be so bright?
Yeah, just wait for a second as you see it, and because sometimes it might be a plane. That's the only thing that might trick you.
All right, so Jupiter won't blink its lights at you.
Right, and it won't move.
So how long have you been observing Jupiter?
Oh, I've been observing, since I first really got involved and first started looking through a telescope and got involved with astronomy, which would have been in the early and mid-90s.
All right, and what are some of your experiences in observing Jupiter over that time?
Jupiter is one of my favorite things to look at, and there's two reasons for that. One is that it's great to look at with any type of a scope, whether you've got a very inexpensive telescope, very small, or one of the big ones, one of the larger amateur astronomer telescopes that we have out there. I've got a couple of images here of something that might be an example of a smaller refractor type telescope, where we have a lens that actually gathers the light. And you can see in this example in the picture, the person would look through the eyepiece near them, or near the lower part, or at the ground, with a refractor or a lens type, which is a binocular, is also a refractor, which is also good for Jupiter.
Oh, I see.
Or if you get some of the larger refractors that some of the amateur astronomers have that are more expensive, or a reflector, even the smallest, simplest amateur telescope that's a reflector using a mirror, where the eyepiece, where we looked in, and there's a couple of pictures there of a smaller example, and then my example, which is one of the larger examples of a reflector telescope, where the eyepiece is at the top. And the key difference with these two types of telescopes when it comes to looking at Jupiter or planets is that a refractor tends to be best for planets when you're looking at image. And there's a lot of positives or negatives about reflector or refractor, the price difference, and how much quality you get of the image. But generally towards planets, refractors are good, especially if you've got a larger refractor. But they all show you something. Even the small binocular refractors show something interesting with Jupiter. Jupiter is so easy to see. Like I say, even with binoculars, it was first seen when the telescope was first pointed to the heavens by Galileo in the early 1600s. And that's when he discovered the first 4 what they call Galilean moons. And we can see those today just with the binocular. You can see these 4 Galilean moons. You
really?
remember
Even in a pair of binoculars you could see them?
Yeah, and there's an image now that maybe we'll have shown on the screen where you can see very clearly the moons, and they are always, if you see Jupiter there in the center, aligned to it, either left or right, you'll see those 4 moons. And if you only count 3, it didn't crash or disappear. It might be just in front of or behind the planet.
And these moons change position from night to night?
Right, from hour to hour. As you watch through the night, if you stay there showing different people and you're hanging out looking at the telescope and you're there for a couple of hours, you'll see significant changes from hour to hour. You know the names of them, don't you, Don? What are the 4 Galilean moons? Io is the big pizza face.
Io, yep. Europa, Ganymede, and Callisto.
Exactly, exactly. So you'll be able to see those with the simplest telescope and see the changing. And so even if you have binocular and you're out in the dark skies, that's an interesting to look at. You know, and you're out camping, maybe not looking at the sky continuously, but you look back and check on those moons and you can see how they change from hour to hour. Jupiter spins very fast. Its day, we have a 24-hour day where the Earth, you know, it makes one complete rotation.
Yes.
Jupiter spins in 9.9 hours, so it's much quicker.
Oh my goodness.
And the moons go very quick as well.
You know, there's a feature on the cloud tops of Jupiter. It's called the Great Red Spot. Anything interesting about that you can tell us?
Oh, yeah, definitely. That's, do you know, before we get to that, there's one other thing I want to tell you about the telescopes. No problem. I want to talk a lot about the Great Red Spot, and one of my other favorite things about Jupiter is that it's always changing. But about the fact that you can use any telescope to use it, I mentioned that Galileo first saw those 4 moons back in 1610,
yes.
But probably with any telescope you use, you won't see the 5th or any other. There's actually 63 moons now with Jupiter. But the 5th moon wasn't found till almost 300 years later when they used a 36-inch refractor, the Lick Observatory, when it was first built. They discovered the 5th moon of Jupiter, so it took a lot more magnification power to see the other teeny 59 moons that there are to see, and that's name is Amalthea.
So they have so many small moons. Did they discover them all using the Lick, or have they been discovered more recently?
They've been discovered with some of the ships that have gone out to Jupiter, like or flew by Jupiter, like the Voyager missions.
Okay. Oh, and perhaps even the Galileo mission.
Right.
As well. Anything else that the folks would want to know about the 2 different types of telescopes looking at Jupiter?
No, now I think I'll get on to your other question about the Great Red Spot.
Good.
And the other thing that's so interesting about Jupiter is that it's always changing. I mentioned that it rotates in about 10 hours. So just looking from hour to hour, you can see lots of changes. And certainly looking from year to year or even month to month, you'll see lots of changes. So when you look at Jupiter, it's, we'll show maybe another picture now that's a little bit more magnification than the one we saw last time. And you'll generally see, but even in the early one, you notice you see the bands, the 2 dark bands, which the upper they call the northern band, and then there's the lower, southern band, and then there's zones and belts, bands or belts, and the white part of the lighter clouds are called the zones, and there's an equatorial zone and a northern and a southern white zones, and those actually flow in opposite directions. They're all clouds, and they're different colors because of the kinds of chemicals that are in the clouds. But the bands or the belts tend to go from right to left, while the light ones, the clouds or the lighter colored, are going from left to right.
Interesting. It's because of the fast spin of the planet that it stretches these clouds out?
The spin of the planet and the type of the chemicals that are in the clouds.
And the Great Red Spot, what about that?
So the Great Red Spot is in the southern band. So if you look at Jupiter and you've got a big enough telescope, which most of the small ones, even the small refractor and reflector that you saw in the pictures earlier, those can detect the Great Red Spot. It might be just you see a little smudge. With the larger size telescopes we showed in the picture, you really be able to discern it very clearly. but remembering that the reflector, or the one that has the eyepiece at the top with the mirror in it as opposed to the lens, it's
Yes.
going to flip the image. So the great red spot would look like it's in the top or the northern band, but it's just because it's flipped. If you look at a tree or a telephone pole with a reflector, it's also upside down.
Oh, it inverts the image. In other
Right.
words, turns
It
around.
doesn't make it left to right, just upside down.
Upside down. Well, I understand that the Great Red Spot is a huge storm. You could fit 3 to 4 Earths inside of it, and it's been around ever since Galileo first trained his telescope on Jupiter, as you said, back in 1610.
And it's a storm, as you mentioned, like a big cyclone or hurricane, and it takes 7 days for that actually to make one loop. It goes counterclockwise. Yeah, I'm doing it counterclockwise, and it takes 7 days for it to make one complete loop in that direction.
And it keeps moving around with the planet in those tops of the clouds with the wind speed.
Right.
That's fascinating, fascinating. Well, you know, we've had a great conversation, and I'm sure you've got a lot more. But what we're going to do is take a short break to show you a public service announcement that I'm sure you'll find very interesting. And we'll be right back with more about observing Jupiter. Welcome back to our program. In the first part, we were talking with Ford Amateur Astronomy Club member Sandra Masica about her experiences in observing Jupiter. So Sandra, you talked about using different types of telescopes. Have you taken any pictures through these telescopes with a camera, or have you done drawings?
I haven't taken pictures, but I love to do drawings. And Jupiter is when I do drawings. I've done drawings of galaxies and other objects, clusters and such that I've looked at. But Jupiter is the one that's really fun to make drawings of because of the changes and because every picture is so unique. I've been taking, I think, the first actual drawings I have, and I brought a couple of them with me here,
Great,
so
great. We'd like
we
to
can
see
show
those.
them. And this is the first one I did, which was in 1999. So this is like 12 years ago. Would have been my first drawing. And one thing I didn't mention is sometimes you can see the shadows of the moons. Sometimes I said you won't be able to see all 4 moons, and it might be in front of or behind the planet. And when it is in front, you don't often see the moon because it's like white on white, but you may see the shadow of the moon.
So this represents, the dark dot there represents that shadow of that moon coming across the planet.
Exactly. And this was, even though this sort of looks like a spot here, this was drawn with a refractor. So the great red spot, if it was anywhere, would be in the bottom area. And so it must be on the back side of the planet in this case. And sometimes you will see, it's good when you're making a drawing of Jupiter to really spend some time, because there's a lot of atmosphere conditions that we'll have, and it'll just sort of cause a small, not perfect
Like a turbulence?
focus,
Like a turbulence?
right.
Right.
So when you focus your telescope, you focus on the moons or any stars in the field to make them the smallest points. But still, it may not see like exactly in focus because of the air conditions. But if you watch, and if the time it takes me to draw a picture could be 10 minutes, and sometimes you're just staring there looking, is there a line, or exactly how far does that line go down or whatever, and it'll just clear up. Like and you really see more details, and you can often see, like I've shown, these connections from one belt to another, and even though you like these lines between the belts or darker portions, and those are, or like little bumps and lumps along and again, this one you don't see. This is also this one's in 1998. and you don't see the great red spot, but still there's a lot of details and fun things to draw.
Now, do you have the great red spot in some of your other drawings?
I do have the great red spot. This is one I drew, this is 1997 again, and there's the great red spot, and it had a huge white oval next to it at the time, and that just happens sometimes. You'll see, and this big lumpity lump on this side, and I saw a moon off to this side, which I drew into the picture. And here's another one that looks very different. The great red spot has dramatically changed over the years, where I've seen it where it actually looked like a darker filled in spot. But lately, and at this time, which this was again in 97, and I've seen it look this way often, where it's a big, like a fried egg, a white thing with a smaller piece inside, and it's significantly lighter than the area around it. As opposed to being darker than the belt here, it's actually lighter than the belt in this particular case.
You know, Sandra, these pictures look like photographs. Does it take a lot of artistic talent and ability to be able to do this? Because it sure seems like it.
You know, it doesn't. It mostly takes the patience. When you see it at first, it's like, boom, there's two straight bands. And it's when you're sitting there looking at it, see, look, there's a teeny little lump on that side, or a curlicue going down that way. And it's good to look at proportions. Like when I draw on the great red spot, I say, from the half of the planet, how big is that? Is that like a half the size of the whole planet, or is it like one teeny tenth of the size? So you use proportions, I'll say, compared to the size. If this, in this case, where you see the edge of the great red spot happen to be right at the center of the planet, and I looked at that and said that from that side to the left there, that great red spot is taking about half the space. So I use proportions like that, and there's not a lot of color involved. You see some beautiful colored pictures with the Voyager and such, but most of it, what you'll see with looking through a telescope, will be black and white type images, or shades of, many shades of gray. I'll show you a couple other pictures.
Please. These are fascinating.
These I drew in 1999, and this is one of the best telescopes I ever used for planets again, and refractor is always better, and this was a really large refractor. It was a 7-inch, a 6-inch, this was a 7.1-inch refractor, and using bino viewers, which normally there's one eyepiece. This particular telescope, and it's a rather expensive one, had two eyepieces that led and fit in and actually like reflected the image out, because when you use, and you're using both eyes to look at an image, you're using all of that brain power. If you're looking with one eye, it's only half the brain, or that part of the brain that you're using. So you can actually, some people find it significantly better, and I saw a lot more detail on those pictures, I think, than I ever saw when I drew Jupiter. And these, I think I were in 1999. In this case, you can see the great red spot and even some little white spots up here. And in this case, the great red spot's on the other side, but I saw these major lines crossing over. And this exact shape, I looked at that afterwards and thought, that shape doesn't look natural. I think I kind of imagined that, or maybe added a little flair to it. And then I was looking at some Voyager shots, and I saw this exact same shape, and a picture that looked almost exactly like this. And so you can trust it, trust your imaging when you're seeing something. And the last picture I'll show is one that I did just the other night. I stayed up. Right now, Jupiter, we're filming a little bit earlier, and Jupiter is up very early in the morning, and so I stayed up late to get something that shows what does Jupiter look like right now. And in this case, the image is flipped. I think all of the other ones were refractors, but this one was done with a reflector. So you see the great red spot in the top. It's still in the southern band, but the image is flipped. And it has this white stripe. The whole belt, the whole southern belt, has this white stripe that kind of cuts it in half, which I've seen before, but not usually in the past, like 10 years ago. So that's something kind of new. And I saw these two little tiny white spots here. And this shows the difference, 3 hours, and what happened to the moon. I started looking at the Jupiter at 1:30, and the great red spot wasn't around. So I went to bed and set the alarm and came out a few hours later, and at 4:30 the great red spot had come around and the moons had changed
So
dramatically.
These two images right here showed the movement of those 4 Galilean moons
Right.
in just a few hours.
Yeah, this is Jupiter, and it's got 3, and you've seen all 4 moons, and again, 3 hours later, the moons are around Jupiter.
That's fascinating to be able to do something like that. As you say, it not so much artistic ability, but rather just patience or perseverance. Be willing to sit out and put in the time to see these details. What's the best scope that you've ever looked at Jupiter?
Oh, that one would be the astrophysics.
The 7-inch that you mentioned?
Refractor. Right. Do you know, there's one other thing I wanted to bring up, and I mentioned a little bit about where you could find Jupiter in the sky.
Yes.
But for those of us who know our constellation, or maybe if you don't know the constellations, this will help you to get to know at least one of the constellations, to let you know where exactly to find Jupiter in relation to the stars around them. Jupiter actually, throughout the summer, is in the constellation
Capricornus.
Capricornus.
Not one of the bigger constellations to remember.
It actually is a very large constellation in the sky, and I don't know, I just had one of those brain blanks for a moment there, but I always think of it as the bikini, and all I could think of was the bikini, because it has 2 little stars that are like here where you tie the bikini, and then sort of it makes a big triangle.
Oh, I see.
Earlier in the summer, in July and August, there's 2 stars here again and 2 here. Right above those 2, almost making a triangle, is Jupiter, and then Neptune is practically right next to Jupiter at that time.
Oh, really?
Now in September, Neptune is moving off towards my hips, and Jupiter is coming in a little bit towards my belly button.
Okay. Interesting way to describe the movement of the planets. I hadn't heard them described quite in that manner before, but as the night progresses, the planet will be easier to see. It'll be higher in the sky if folks want to see it.
Right. Capricorn is right between the teapot, Sagittarius, and then it rises right after the teapot. To the left of the teapot.
Will we have Jupiter in our skies for the next several months to be able to enjoy it?
Yeah, I'm not sure when it gets to the point where it's so far west that it sets before, but it should be in the sky for
quite a few months,
several months to come.
Fascinating. Jupiter is, of course, the largest planet in our solar system. It's the first of the 4 gas giant planets in the solar system, and been a source of fascination and observation for centuries. I want to thank my guest this evening, Sandra Masika from the Ford Amateur Astronomy Club, sharing her observations and drawings with us. If you would like to learn more about this, go to our website that you can see showing at the bottom of your screen. If you have a question about Jupiter or anything else astronomical in nature, send us an email at the email address that's also at the bottom of your screen. Want to take a moment to run past some of the upcoming astronomy events here in southeastern Michigan. Coming up on the weekend of September 25th is the 13th Annual Astronomy at the Beach. With me is John Schroer, a member of the Great Lakes Association of Astronomy Clubs, to tell us all about it. John, what's this program all about?
It's reaching out to the public to help them understand and begin to enjoy the hobby of astronomy. It's sponsored by the 7 major clubs in the area, such as the Warren Astronomical Society, the Ford Amateur Astronomy Club, as well as the Cranbrook Institute of Science and the Detroit Science Center.
So what can people expect to see when they come to Astronomy at the Beach?
Well, first off, we're going to have, it's at Kensington Metro Park at Maple Beach, and they can expect to see dozens upon dozens of telescopes. They'll be able to look through and look at the sun, whatever planets, the moon, and other objects in the nighttime sky. There'll also be hands-on activities for children. The Science Center will be sponsoring a star lab, a portable planetarium, so if it's cloudy, we still show the nighttime sky. We'll also have a series of speakers talking about beginning astronomy as a hobby. The main speaker is Bob Noye. He's editor-in-chief of Sky and Telescope magazine, and he'll be talking about how amateur astronomers are helping in the search for planets orbiting other stars in the Milky Way galaxy.
Will there be other speakers besides Bob?
Most certainly. There'll be speakers from Delta College, Eastern Michigan University. There'll be members from the astronomy clubs such as Gordon Hansen from the Ford Group. We'll also be doing talks about introductory astronomy techniques, how to get interested and how to get started in astronomy.
Does this event cost anything?
There is a charge to enter Kensington Metro Park, but other than that, there's no charge, and it's Friday and Saturday evenings.
That's great. Well, John, we want to thank you for filling us in on this exciting upcoming event here in southeastern Michigan. Want to thank you for joining us for our program. We hope you enjoyed it, and we hope to see you again next time on Astronomy for Everyone.